Let's move our next topic, which is receptor solution. So there are three different tests to qualify a selected receptor solution for an IVRT study, and it is described in a cyclovir cream guidance. Basically, one need to show the adequate solubility of the drug in the receptor solution and maintaining syn condition. We already discussed earlier today what represents adequate syn condition. So I think we don't need to discuss that again. The next requirement is the drug stability in the receptor solution and also showing acceptable release profile. One thing that I think we can clarify here is at what temperature should this solubility and stability studies to be conducted? Are they conducted at room temperature or 32 degree or a higher temperature than 32?
By the way, which slide are you intending for us to be viewing right now?
The receptor solution slide.
So we're still seeing the apparatus selection slide.
Are you sure?
Sorry, I am.
I am as well.
Yeah, you all are same.
I am as well.
I think that's the
okay.
WebEx.
I can stop share maybe.
Yeah, it seems like something is frozen.
Mm-hmm.
Okay, can you guys see it now?
It's just coming up. But I'm so sorry. Can you repeat the question?
Sure. The question is, at what temperature should we evaluate drug stability or drug solubility to qualify the receptor solution?
Okay. I can comment, but if others would like to jump in first, please go ahead.
Please do.
Okay. So I think there's two considerations. One is what the drug is experiencing when it's inside the diffusion cell in the receptor compartment. And there, you're thinking about the receptor compartment temperature, which is going to be close to 32, but it's 32 plus or minus 1 at the membrane. So it could be up to 33 degrees at the membrane. And the receptor solution, could be 33 or, maybe even a little bit higher. So I think it's prudent to be able to think about doing the stability studies at a slightly higher temperature. So that's one of the things as part of the HPLC validation that we wouldn't necessarily routinely do in terms of your benchtop or long-term stability, but to be able to do stability at, let's say, 34 degrees, for example. But then there's also the consideration of the fact that your procedures may involve drawing that sample and then having it sit at benchtop for a certain amount of time or being in a fridge for a certain amount of time. So I think those are the sample handling considerations that can also be taken into account in terms of the stability piece of it. I think it's so in terms of solubility, similarly, the solubility might be excellent at 32 degrees, but then what if the solubility is much lower when it's then sitting out at 21 degrees, or for that matter, even if you're freezing it. But I think it's helpful to think about the fact that you don't want your drug to be crashing out when it's on the bench before you inject the samples. And so I think there's a few things about the process that go hand in hand with the considerations that you were asking about.
Yeah.
Thoughts from the group?
Yeah, yesterday Leandro pointed it out in developing bioanalytical methods that you really need to worry about the fact that oftentimes the autosample temperatures are 5 degrees or room temperature, and then you need to make sure that your drug is not going to precipitate out, because typically the receiving medium temperature is more like 33 or 34, right, Christina? So it's about that. So you really need to have a range. So you really need to have to determine stability and solubility at over a range of temperatures, not just one temperature.
So
We
I'm
can
not
see
seeing
your
your slide yet, by the way.
Yeah, I don't know what is happening because I'm sharing it and I can see the videos are fine.
It's text for you.
I'll try to, instead of sharing the screen, sharing the content. See if that works.
That's coming up. One comment regarding the stability of sample. Many times in the IVRT, your detection level is well above lowest level detection. So you have enough sample in your solution that what you can do is draw your sample and then immediately dilute it to some degree in an organic solvent to minimize the risk of your sample crashing out, as well as any other handling that the sample will go through before analysis. So if you have enough room at your quantitation of your HPLC method, that would be one approach to mitigate against the potential solubility changes of your sample, is to immediately dilute into a mobile phase or other appropriate solvent.
Okay. Sorry for the technical issues.
Anna, do you want to
I'll-
send it to me?
Yeah, I'll let you know where I save it in a second.
So Tanaz is just gonna send me. If you want to drop it in Teams, then I can pick it up there as well. So she'll send it to me, and I'll see if I have any better luck presenting it from my side. While we have this opportunity, there was a nice discussion in the chat about the PVT and the discontinuation a few years ago of the Tufrin membrane. Kelly, do you want to comment on that and how PAL has, and on the PAL website, they even talk about moving over to the polyether sulfone, the Supor membrane?
Yeah, we had I think we did use Supor. We didn't use Tufrin for our PVT analysis, and that's perfectly all right. They are very similar. Supor is polysulfone and Tufrin is something similar. So it's okay to switch the two. In fact, I don't really like Tufrin because in many cases, Tufrin showed more binding of the steroids than some of the other inert membranes. And so I think it's perfectly okay to switch over to all other membrane.
Okay, so I didn't remember which membrane was published in the method. Was it Supor?
The method, I think at that time it was still Tufrin, Sam, and then might have been Tufrin. But I think we need to, because traditionally, I think historically for the steroids, we know that everybody has used Tufrin a lot. And USP also did a collaborative on using Tufrin in those days. But then I think we evaluated all, and I personally had not necessarily wanted to use Tufrin. So we have used nylon and Supor in many of these occasions. Christina can go back and confirm it. I don't know what we use, the data I presented, but I would be surprised if it was Tufrin.
So I think if it was already Supor, there's data with that, then I think we're good to go. If not, it would be good to update USP, maybe just with some updated data on that. Okay, so I have Tanaz's presentation. Tanaz, would you like me to present then on the receptor solution? Okay.
Someone is sharing now, and I can see the slides.
Yeah, we can see the slides. Yeah, we got it.
Okay.
Okay. I think the next topic that we want to discuss is related to the nature of this receptor solution. as we heard from our other speakers, most of the receptor solutions that are used are hydroalcoholic mixtures. We got a lot of questions from audience whether they can use strong organic solvents such as THF or DMSO, whether they can use aqueous solutions only. Would you guys please comment on that?
I think it's perfectly okay to use hydroalcoholic solvents. You use the stronger solvents only in case you have to worry about the environment, the safety aspects of using some of these stronger solvents because you're using it higher temperature. There are vapors all around. That was one of our considerations. And typically the IVRT systems are not in any kind of hood or where they can vent out these solvents. So that should be considered when using strong solvents.
Yeah, and I think we also have to consider evaporation when using a large ratio of an alcohol, especially when you're trying to measure the temperature of the membrane and things like that. But it definitely is often used. We've never used DMSO in any methods that I'm aware of, but we typically try to stick to methanol or ethanol, things like that.
We used that for the example I cited, Christina, and we used DMF in some cases.
Okay, yeah, in my experience, yeah, I think that was before my time. In my experience, we try to stay away from anything that also is going to, like you said, any health hazards or anything like that, and it's also going to have a lot of smell also in the lab. So we consider a lot of environmental, aspects too. So
yeah, the petrolatum ointment we use the THF also with a mixture throughout the solution as well, and we can consider, of course, if you're getting good linearity, good release, there is no limitation. Of course, it's not interrupt to the analytical method as well. Yeah, and the solution can be considered, including DMSO.
We cannot hear you, Sam.
Sam, you're muted.
I apologize. There, you can hear me now, I think, right? I was just saying that I'm so sorry. We've lost Tanaz, but I'll see
Back.
if.
I'm sorry.
Oh, you are back. Okay, excellent.
Yes, I mean the solution I think was I had to log out from WebEx and then join back. So
Okay, would you like me to move to the next slide?
sure, thank you.
Sure.
Okay. So I think did we discuss the previous one, Sam? Having two drugs in the formulation?
No, we did not.
Okay. Let's discuss that. What considerations related to method development needs to take into account when you're developing an IVRT for a formulation that contains two API? Kailas, do you want to chime in?
Sure. I think that if your two APIs are similar in chemical properties, then it's a no-brainer. You can most of the time develop one IVRT method. That would be ideal. And then as far as the analytical method is concerned, depends on what kind of separation you have. And once again, if you can develop one IVRT HPLC method, wonderful. Then you just have, that's not same consideration apply. But that's a ideal case scenario. That doesn't always happen. And then if you have two, then you have to, we oftentimes have to develop two separate IVRT methods for very different two APIs, and then just have to deal with it sometimes you would be able to use one HPLC method. It all depends. It's all case specific, but basic considerations are all the same for developing the IVRT method in each case.
We had a case, I'm sorry, we had a case when you have the very high lipophilic active and the hydrophilic active. So we have to split the method even using for the normal phase HPLC and the reverse phase HPLC. It was extreme.
Yeah, I think one of it is just, the first part is just feasibility. Is it even feasible that you can have a receptor solution where you have, adequate solubility and stability for both of the APIs? Maybe the answer is yes. Can you do a single injection for your HPLC method? Maybe the answer is yes. The other is a question of optimization. You may be able to do it, but it may not be a great method. And so that's part of where you look at it and you've got to make a judgment call. Am I satisfied with this method? It's feasible, but boy, it's ugly. In that case, you may just want to have to, look at, I might be able to do much better and ultimately have a more validatable method and a method that I don't have to go to a stage 2 and I'm just biting my fingernails as to what's going to happen with the thing. You might have to make a judgment call early on to say, look, it's kind of feasible, but I'm just not happy with the precision or the reproducibility or the linearity, or I'm just making too much of a compromise here, and I'm going to separate them into separate methods for which I can really optimize conditions for the release of each of them, and then similarly for the analytical.
So we just received a question from audience that if you use one IVRT method for both APIs, are you violating Higuchi's equation?
So you have to consider then you not necessarily, because if you then you can pay attention to the percent of dose depletion that you have, and you can stay in the lower side. That way, you are, well, you do need to think about that, because the assumption is that approximately 30% of the dose, when it's diffused, then the equation is valid or that's the assumption. So yeah, one can stay. You don't really have to have 70% dose depletion. You can stay around 35-40%, and you'll still be able to meet the criteria.
Okay, thank
So
you.
I'm not sure I understood the question. I don't know if that was related to this 30% issue. So,
Yeah.
again, my interpretation of, William Higuchi's paper is simply that he said, here's the construct, here's the squared approximation. All of this should hold as long as something in the system is not terribly unbalanced. For example, let's assume that dose depletion is no more than 30%. That's a pretty safe assumption that the system is not completely out of whack and everything should hold. That didn't mean that anything beyond that is a violation. I'm not sure whether two APIs, if that's what the question is referring to, but I must confess I don't really understand. I'm just not making a connection with what we'd be violating there.
Well, I think from what I understand, they're probably talking about the basic concepts of diffusion because there are two. When you're talking about two different molecules, so if you less combine the two, then you have so much API in the receiving chamber. If I understand the question correctly.
So I think that makes sense, but a lot of the theory is a little bit idealized. The idea that when you're looking at that receding boundary of concentration, or that when you're getting diffusion from the dosage form, that the only molecules diffusing from the dosage form into the receptor solution are drug. And then everyone said, I can't pass immigration. I'm sorry. Come on, that's just not what happens, right? So whether it's one molecule or two molecules, I appreciate the point that, technically, got a lot of crossing of the border there, but I don't think it's violating anything. I think that's just the reality of what happens.